Welcome back to my channel. This is Kidomuju from KD Concept Researchers. Please kindly like and subscribe to our channel so that you can always get our videos while it drops. These three group of persons. Now, let's say we want to do a pairwise comparison of data. Let's say we have a set of data, then we want to check. I have the data like that here. Excuse me. Now, I have this data. This is like water from two different boreholes connected in dry season and rainy season. Now, we have the borehole 1, borehole 2, and the control for both wet and dry season. Now, the objective here now is to check if there is a significant difference between the borehole 1 dry and the control, and also if there is a significant difference between borehole 2 dry and control. Now, because at this point, we are just considering two variables, that is borehole 1 and control, or borehole 2 and control, it is best now we use what we call the t-test. Now, t-test is equivalent to ANOVA, but it handles just two data points, two data sets. It does not handle more than two. Where the variables to be considered is now more than two, that is when we opt for ANOVA. If it is two, we use our t-test. Now, observe how, pay attention to how we do the t-test. It's similar to ANOVA. So what am I going to do now to check is the difference between the borehole 1 for dry and the control values here. This control is like the standard values. So some person just use them as control. We don't know where the control is coming from, whether from NAFDAC or WHO or NESRA, but that's not our problem now. We just want to check the performance of this borehole 1 with respect to physicochemical parameters and the control value. Now go to data. We also go to analyze data. Now I'm going to tap T, and it will take me to t-test. T-test paired two samples for me. Yes, that's exactly one. T-test. Then I will OK it. Now, t-test, because it uses two samples, it will ask you to enter your variable 1 range. So my variable 1 now is my borehole 1 dry. I will select the entire data. And then my variable 2 is my control. I will highlight it. I'll highlight my control. Then also ask it to add label and set my alpha level to be 0.05. Remember, what you are computing now is the t-test, not the ANOVA test. That is why we are taking just two variables, for 1 dry and the control. So I will OK it. Awesome. Let me zoom out this result a little bit and also expand the columns. Good. Now, this is the result of the paired t-test between borehole 1 dry and control. You see the mean, you see the variance. The hypothesized mean is 0. That means there is no significant difference between them. That is your null hypothesis. Now, down here, let's look at the performance of these statistics. Let me zoom it out. Now, a statistical test will have both the one-tail test and the two-tail test, but our interest is in two-tail test because it is two-tail test that check if there is significant difference of change. When you talk about change, that is, has it increased or decreased? But for one-tail test, is talking about if it has either increased or decreased. So our interest lies in the two-tail test. Now look at the performance of two-tail test. The critical two-tail is 2.11, but we cannot judge with this. We can only judge with the p-value of the two-tail. Now the p-value of the two-tail is 0.02, and 0.02 is less than 0.05. Therefore, this test is significant. Look at this value here. I'm going to flag it. It is a significant value, 0.02, because 0.02 is less than our assumed level of significance, which is 0.05. Therefore, we can conclude now that there is a significant difference between the performance of borehole 1 dry and the control value. Now, if that is so, it simply means that the physicochemical parameters from borehole 1 is not within the standard or control limits. Similarly, we can also do the same test for between borehole 2 and control, so that we can now compare the results. So again, we are going to go to data analysis, t-test. Now my variable 2 will not change because that is the control. What is going to change now is my variable 1, which will not change from borehole 1 to now borehole 2. So I will highlight my borehole 2, and then the control range is still here, which is intact, but just in case I can also re-enter it. Highlight my borehole 2, then okay. Now I'm going to copy the results of borehole 1 and borehole 2 and put them side by side. I'm going to highlight this, right click on it and copy. Now let me paste it just by where we have the borehole 2. I'll use Ctrl V on my keyboard to paste. Now look at the performance of borehole 1 and borehole 2. This one is between borehole 2 dry, while this one is borehole 1 dry. Now, if you look at the p-value for borehole 2, you find out that this p-value is 0.519, 0.516. So you can approximate it to 0.52. Now, this is not a significant p-value because 0.52 is greater than 0.05. That means with respect to borehole 2, there is no significant difference between borehole 2 and the control value. So that means the borehole 2 is a better water sample as compared to borehole 1. Because since it has no significant difference with the control value, it means every value in the borehole 1 is within permissible limits of the control. However, the borehole 2 is different. So with respect to this now, with respect to checking for t-test, when the test is significant, it means that there is difference between the two variables you're testing. But where the test is not significant, it means there is no difference. So the null hypothesis with respect to t-test, the H0, which is null hypothesis, is stating that there is no significant difference between the two mean that you're about to test, while the alternative hypothesis will be stating that there is significant difference. So in this first case here now, when we tested for borehole 1 and control, this one we are going to reject the null hypothesis because there is significant difference. Why between borehole 2 dry and control, there is no significant difference. So borehole 2 is good. Is a good. In fact, I think this the one that is good is one that should be on blue. Why this one that is significant, I'll flag it red. So let's come back to the data. Now looking at this data, the borehole 2 is a better water as compared to borehole 1. Now one may also want to check between borehole 1 dry and borehole 1 wet, others here, which you can explore at other times to find out what they do. So basically, that is what we have done between yesterday and today, how to do basic statistical data analysis. Remember that the most important analysis that you can do to any data is to get the descriptive statistics. Then after you've gotten the descriptive statistics, you can now go ahead to conduct inferential statistics. Inferential statistics is things like ANOVA or t-test, where you have to draw a conclusion based. Thank you for watching this video. You can also check out some other videos that are prerequisite to this one on our course series in data analysis using Microsoft Excel. Please kindly leave your questions in the comment section and we'll attend to them. Also remember to like, share, comment, and most especially please kindly subscribe to this channel so that we can always serve you better. Thank you.